Hello and welcome to our webinar today. My name is Sebastian. As a member of the CovidGraph.org team, I'm doing this webinar today. And in my daily job, I work as CTO for yWorks. We're the diagramming experts. If you want to learn more about diagram or graph visualization in general, outside the scope of the CovidGraph project, feel free to contact me or yWorks directly or find us in the various networks. Today, however, let's hear about CovidGraph and how it can be explored. This is my agenda for the session today. I'll tell you more about CovidGraph.org, how it came to life, who is involved, and what it's all about, and even how you can possibly participate. I want to start by giving you an overview of the data that we've been aggregating and how we actually did that. But most importantly, I will show you where you can see and play with that data live using our Visual Graph Data Explorer. I'll show you how to use it and some of its features. And in the second part, I will go into more technical details, showing how we are managing and organizing the data in our knowledge graph, specifically how we are managing the schema in our Neo4j graph database. And from there on, I would like to briefly show you how you could create your own visualization app that works with our datasets or your own, as well as what tools we use to build for our first Graph Explorer app. And this actually in just a few days. We will then end with a Q&A session. So if you have questions, please do type them into the chat. I will go through them at the end and will try to answer them as best as I can. So let's start with a quick formal introduction of the CovidGraph project. It started in spring 2020, shortly after the world got into this pandemic situation that we're still in today. And it's a collaborative effort of a actually growing group of people who were connected through their use of graph databases in their daily work. We're trying to help researchers fight the virus. This is how it started, but you will see that there's more that we can do with our tools and technology. And we do have plans to work together on other and new projects in the future too. However, for CovidGraph, it was this call to action that I saw on the social networks early in the pandemic. Researchers around the world were publishing research data about COVID-19. And so the software development community was asked to help with analyzing this information and make it more accessible to researchers. Usually by the time that I stumble upon such interesting data sources, the community teams at Neo4j already had been there and had loaded the data in some database instance for everyone to play with. But this time I was actually first, and I couldn't believe that no one seemed to have had the idea to load all the connected data into a graph database as a knowledge graph for others to build new use cases from. So I used my social networks connections and asked for help. And actually only 3 days later, I had found Martin Preusse from Kaiser and Preusse and Alexander Jarasch from the German Center for Diabetes Research. Martin was very quick to set up a Neo4j GraphDB instance and loaded the first datasets into the DB. And with Alexander, we had not only the bioscience background on board, but we could also connect with this huge social network so that within just weeks, we had many of Europe's big players in the graph database ecosystem on board and contribute to the project. During the first few days, the team created a Docker-based ETL, that's extract, transform, and load, build pipeline that loads the data from various publicly available sources into a single large Neo4j database instance, generously provided by the folks of Neo4j. Thanks for that. This enabled us to conveniently query the publicly available data from those many different sources as one huge connected knowledge graph around the topics of medical publications, patents, genes, and various other biomedical databases. You can find the pipeline on the GitHub repository of the project. It uses orchestrated Docker containers to load the data from external sources, transform and prepare it to load into the Neo4j database. We connect the entities and the data points in the data using both simple text matching algorithms as well as natural language processing and named entity resolution algorithms, forming a network of millions of interconnected items, each with various properties and detailed background information. The database interface is publicly accessible for programmers, and we provide a number of apps for end users that connect to and query the database on CovidGraph.org. The app, however, that we built first was the CovidGraph Visual Explorer. You can find the sources for that app on GitHub too. You can launch the app from the CovidGraph.org homepage. Just scroll down to the app sections and click it. The Explorer is a simple single-page application that anyone can use. No downloads, installation, sign-up, or registration required. It directly connects your browser with our public database. This setup allowed us to move forward quickly and also, of course, save hosting costs. Once it has loaded and you close the splash screen, it shows a boring, empty canvas. Luckily, we have this nifty, simple search bar at the top where, as a user, you first determine what kind of entity you want to search or start your exploration with. You can use a text field to enter words or names for your query. If there's a unique match, it will directly load that entity and add it to the diagram. If there's more, like in this case, than one possible match, you get a textual preview of the matches where you can optionally apply second-level filtering and decide which elements to ultimately add to the diagram. The app will then automatically determine connections between the elements on the screen. In this case, it's genes mentioned within papers. Once you have some elements on the screen, you can use the context menu to explore related entities. You will see a number showing how many related elements by type for each element there are. And if the number is large, again, you can filter the elements via an additional table view before they are added to the diagram. This way, you can find scientific publications and patents that mention genes in their abstracts or full text bodies. You can find out what transcripts are coded via genes, which pathways relate to a gene, and so on. You can also find out who wrote or co-authored patents and articles, and what institutions and companies are affiliated with the publications and patents. Just try it yourself later, please. On the left-hand side, there's a tailor-made details panel that shows for each selected item more details that are stored in the database. As you will later see, not all of this information is stored directly with the corresponding entity in the database. Instead, we also use the view for aggregating additional information that conceptually belongs in the view, but is stored elsewhere in the database. For example, you can view the aforementioned full text and abstracts of the papers and other details. Also, there can be links to third-party pages where you will find more information, and you will find previews of related items, which you can conveniently add to the diagram without having to go through the context menu. More sophisticated queries can be executed with simple gestures. For example, you can select elements of the same type and find mutually common related entities. In this example, we are looking which other publications have been submitted by a set of 2 authors. Also, you can find the missing link in between items. So if you want to know whether a gene and a protein both relate to one or more transcripts, the tool will automatically construct the elaborate database query in the background and answer that question visually for you. These kind of queries work for other multi-level transitive relationships too. And last but not least, for those who really want to work with the raw database, there are also options to automatically generate a Cypher query for you that you can use in other apps to identify the items from your database. In this example, I copy the Cypher query and execute it in the Neo4j browser tool. As you can see, even though the elements were connected in the CovidGraph Explorer, the low-level database tool did not show these connections. Why is that? The answer is that the actual structure of the database is a lot more complicated than it appears in the Explorer app. There's not just a handful of different entity types and relationship types, but many, many more. The database schema is much more complex. The many data sources that contribute to our knowledge graph result in a pretty complex, but also very versatile database schema. The app hides this complexity of the schema and dynamically generates a convenient view of the data in memory. I'll show you that there's much more under the surface. Even though typically a graph database does not have a static or strict schema, the way we load the data into the database, we implicitly also define a schema. We needed to have a very good understanding of the schema, both in order to know how to best integrate new data sources, but also in order to create helpful queries and ultimately some useful applications for end users. Database administrators and software developers use various tools for managing their database contents and queries. In the case of Neo4j, there's even a simple Cypher utility function that will show a simple presentation of the schema. I personally was not part of the team at CovidGraph that implemented the data pipeline, but I wanted to implement the Graph Explorer app, for which I needed to have a basic understanding at least of the structure of the data. That's why I used the tool that we at yWorks had built and given to the Neo4j community as a free-to-use tool a few years back. It's the Data Explorer for Neo4j. Anyone can use it to conveniently browse the schema of their Neo4j database and to also actually browse the data in a similar way that I just showed you with the CovidGraph Explorer, but just for generic databases. But the main benefit for us was the automatic presentation of the database schema. Automatically deriving the schema from the data has the advantage that your schema is always up to date and does not need to be maintained or synchronized manually. Because if you need to do that manually, you either lose your agility or your documentation quickly becomes out of sync with reality. We wanted to deliver fast and stay agile, so we used this tool. So let's quickly see how it works. As a database admin, all you need to do is point your browser to yworks.com/neo4j. There's a link that allows you to open the Data Explorer web application. Again, no download fee nor registration is required. A desktop browser is all you need. Don't worry about your data leaving your systems after the app has loaded. You can even disconnect from the internet. The app will directly connect your database and data is only exchanged between your database and the browser. It never touches any third-party servers and systems. That's the beauty of a rich client-side JavaScript application hosted from a static web page server. Once you loaded the app, you can enter your database details. Read-only access is enough for the app to work. After connecting to the database, the app will start by loading the information about the schema in your data. In the end, it will show a neatly laid out, automatically generated diagram showing the different entity types called node labels in Neo4j and how they are related to each other. You can find more information about the properties stored with the nodes and the relationships, what indices are used, etc. For your convenience and in order to focus on certain aspects of the schema, you can temporarily hide elements from the view. You can use the different layouts and export the visualization to our, actually also free, generic diagram editor application Wired Live, where you can get more creative and finally export the diagram to various high-quality image and vector formats for inclusion in your documentation or other documents. This is actually how I create the schema diagram in the slide where I introduced it to schemas. So you can just edit this like generic graph visualization. It's really anything you can do. But let's get back to the core features of the Data Explorer. While working with a database, I was able to stay in that tool. I didn't have to leave it. It was helpful when I needed to plan and design my database queries and validate their correctness. There's a second tab in the app that switches from schema view to data view. Similar to the other generic data exploration tools, it lets me iteratively explore the data in my database. Via this dialog, I can search for elements via the simple UI. No need to use Cypher for the simple queries. But there's actually also an option to directly enter Cypher queries. But not having to type queries, of course, saves me from typos, which happen frequently when I'm working with a new database schema. Again, I can load the elements and then put them on the canvas. Clicking the elements shows me all the properties, and via the context menu, I can load more related data into the visualization. So far, this is all very basic. But I can do more advanced things. As I said, I can enter Cypher queries directly, and I can let it create some Cypher queries and copy entity IDs for me so that I can use them in my apps or other Cypher-based tools too. Also, if I want to, I can share my presets easily with others just by sending a URL that contains my settings. But there are some more truly unique features. For one, I can use a built-in node template design tool to specify what information I would like to see in my diagram and how it is presented. For example, in this case, I can add icons and additional visuals, and they can be data bound to the data that's stored in the database. Colors, sizes, shapes, images, gauges, and all of this can be added to the visualization this way and then automatically update based on the data in the database. So here we are binding the text field so that we can actually see the name of the gene symbols. And once we're done, we get to see that this template gets applied to all the symbols. This is all enabled by the underlying software library yFiles. And of course, this also means that I can run multiple different automatic layout algorithms on the graph that I'm exploring, and for example, to highlight different aspects of the structure of my data and a lot more. But I won't be showing these generic features today. Instead, another feature that we used extensively during the making of the CovidGraph Explorer was working with transitive relationships. These are relationships between two entity types which are not directly connected in the database, but instead are multiple hops away from each other. The situation is very common in our data, and it makes modeling the data a lot easier because you can have more entry points. With this technique, we were able to connect multiple data sources with different structures together easily. However, from an end user perspective, like in the Explorer application, we would rather not see all the steps in between. The ability here to declare these relationships and only use them in the view gives us the best of both worlds. This way, as a software developer, I did not need to go to the database admins and ask them to kindly restructure their data just so that I can visualize it. In this example, you see me declaring a transitive edge between a paper and genes that I mentioned in the paper. We saw that before. And as you can see, even in this generic tool, you can make this happen. Not as comfortable as in the bespoke application, but almost. That's all good and fine, but this tool itself still remains, as I said, a general purpose tool. So even if you can fine-tune it quite a bit to better suit your specific database schema, for the CovidGraph project, we wanted to have a more accessible tool that doesn't require working with these complex user interface. It should be almost trivial to use and help answer exactly those questions that researchers would have when working with the data, but not more. And we didn't want to confront them with all the details. That's why we created the Explorer app as a separate application. In fact, the Data Explorer here itself can not only help in understanding the database and planning for queries, It also connects to another yWorks tool, which helps software developers to easily get started with the creation of their own apps. From the menu, I can export my settings to the app generator utility. This other tool will help me scaffold the source code for my custom code visualization application. It will automatically import the Cypher query and the database connection settings and set up a basic application structure to help me as a developer to get started. Don't get confused by yet another graph you see in here. That graph basically only depicts the pipeline for what my app will do. As a developer, I can configure the app and then ultimately choose my favorite application framework, programming language, and the features that I'm interested in, etc. And finally, I get a source code bundle that I can download and open in my developer tools. You don't have to use this kind of low-code tool to get started to create your own application. And in fact, when we started the CovidGraph Visual Explorer project, this app generator did not even exist. So we built the app really from scratch, just with the help of the generic graph visualization library yFiles for HTML, the Neo4j Bolt connector for JavaScript, and Vue.js and Beautify, which is a set of basic UI components that I add these nice buttons, menus, and lists to our app. It took us literally just a few days to come up with the first version. But since then, we have been constantly improving the app based on the feedback of the users. We hope that you will be one of them soon too. So that's already for my short introduction to the tools that we use and to the app that we built. Now to your questions. I hope you found the time to type them into the chat. If not, this is now your last chance. And also, of course, feel free to contact us or follow us on Twitter or LinkedIn or GitHub, or use the CovidGraph.org website to make contact with the team. Should you be less interested in CovidGraph itself, but interested in the diagramming tools in general that I used and showed, please contact me or yWorks directly. But let me see whether there are any questions. Okay, there's one from here. Does it also work with real data, with streaming data? I guess it means with data that actually updates live. That's a clear yes or no. Currently, the CovidGraph project loads the data via this ETL pipeline that I told you about. And this runs regularly, but doesn't enter any live data. Meaning, what you've seen is basically a snapshot of the last state. The app, however, is built in a way that it always queries the latest state from the database. So if the database actually updates in between, you would get to see the newest features. Updates, however, don't get pushed to the client in this example. This is not a restriction of the tools we used in here, but it's just something that we didn't foresee in this application because there are very little live updates in the data that we have. So conceptually, it works with real data, streaming data, but not in this application. We are not using this in this application. Another question: could you have a link in the DB that connects to a service returning an image for a node? Yeah, exactly. Yes, you could. Maybe I can even explain how that works. When I designed this template, you may have seen that I added this image over here. And in this case, it really was a static image. But just like with the text table over here, where I actually reference the data in the database, in this case, the SID. Don't ask me what SID actually stands for, but that's that's the ID in the database where it says ACE2. I could just as well use this as part of my URL for this image. So I could embed the name of the of any or the value of any data that is associated with the node, and add this and from this construct the URL to load the image. So it doesn't the data doesn't have to be inside the or doesn't need to be inside the database. It just need to have a way to be able to construct where that information comes from. And as a software developer, I can use I have all of this information, and I can use them in code. So even though this is a visual tool that helps me do this with only little coding, I always have this last escape hatch where I can go down and write actually some code which does some complex logic in order to run the queries and influence the visualization. So yeah, that's possible. Again, in this application, we were only using static images, but we could have just as well added live images, just as we included the text, not live, but from different sources. And another one, thank you. Yeah. How do you collect information from NCI? Is it made on the fly, or do you have it preloaded in the database? This, to be honest, I don't think I can answer. This is probably something that the database guys can tell you. I will. I think you left your name, so I will tell the team to contact you to answer that question. I have it recorded. I think they're using it. They're doing this as part of the transform and load process, but I'm not really not sure, because I'm just the technical guy. I don't know much about the databases and actually the bioscience behind that. Another question is, can we run graph algorithms, for example, clustering, and see the results visually in the tool? Yes. Depends a bit on what tool you mean. This tool, for example, does have a couple of some simple algorithms included. So you can do things like calculate centrality values or closeness centralities and so on, and they will be, in this case, just rendered as labels on top of the data. But that was basically my main point, was to show that, or to explain that these more sophisticated use cases can be implemented, can always be implemented when you actually have access to the source code of these applications. And if you actually look at the on the GitHub page of the project and take a look at the source code for the CovidGraph Explorer, you will see that it's actually not that much code, and you can literally take this code and modify it to work with your data, and then use either the sophisticated graph analysis algorithms that you get from graph databases like Neo4j and others, or you can use the ones that we also provide in yFiles, which run live on in the client during just for the visualization. Of course, yFiles is running in your browser and only has access to the data that is loaded for the purpose of visualization, or maybe a bit more, but not the complete data, which just wouldn't work. But oftentimes you can run these algorithms on the subset of the data to on that specific subset that you're interested in. So if you know that you're interested in a certain set that you are seeing on the screen, then you can choose between running those algorithms on the server or even running them right inside the browser and using the results to drive the visualization or the interactivity, meaning you can like map the values to colors, of course, which is a very frequent use of these values, but you can also drive interactivity, like only show me the top 25%, or make sure that the dark blue nodes are rendered at the left side of the graph, and so on. So, but the more sophisticated your use case becomes, the less likely it is that you can just do that via configuration. So this is all just a thin layer on top of the database access and the yFiles visualization library. And if you so anything that you see here, of course, can also be done in code. And if the interface isn't powerful enough to realize to let you implement your use case, there is very likely that you can go to the code and ask the developer for you to implement that with the tools that we're using here. So Neo4j and yFiles definitely have the ability to run graph algorithms like clustering. And the visualization in the tool is also possible. There was there was a second part of the question about the image nodes. I mean, a different image per node to reflect of course. Yeah. Yeah, that's actually the simpler part of the answer. Of course, you can, for each type of entity, you can have a different shape, a different size, different number of properties shown. So any property that you have stored in your data, you could use for actually rendering on the screen, just like we did in the CovidGraph Explorer, where we in this case we chose a single graphic. We could also include that information directly in the template. So if for your use case it would be important to know, for example, if there's a publication and there's some paper about, I don't know, Angio, that's this one, and you know there's a paper and you want to know when it was published. Yeah, actually we have this. You could put this right in the visualization. So together with icons, as I said, gauges and progress bars, and you can even make them interactive so that if you click on them, something happens. So this is just a very basic interaction of course here, but you can add actually selection lists, even tables inside the view if you want to go that far. So really, there's hardly anything that you can't do in the visualization. It's more, oftentimes it's more the question of whether you should do it, because you don't want to overload the user with information. This is actually a feature that we're showing here, that if you zoom out, take a look at the text, if you zoom out, we switch to a simpler visualization, because at this zoom level you wouldn't be able to read the text anyway. But it doesn't have to be similar. It could be something completely different. And if you look at our examples, there are much more complex node visualizations too. In the case of CovidGraph, we have rather simple entities, and we chose to go with these simple pictograms only. Another question is, any plan to support RDF and SparkPool? Again, this question, the answer depends on what part we're talking about. I know, for example, that I think that the Neo4j database just recently announced support for query endpoints which support that. Our data explorer at the moment, this one over here, specifically is using Cypher, but we have been working on a version that on pretty much the same interface, working with SparkPool 2. And if you look at the diagramming library, it actually doesn't care what data source you're using. So it could be any source of data, as long as you can get that data into the browser or into the platform that you want to support. In the case of yFiles, you can just use that data to create your graph, and it really doesn't care where the data is stored and how it's entered and how it's transferred to the client. So whether you do it via REST APIs or GraphQL, or as we did it with bold WebSockets, bold binary data, which is very efficient, by the way. It really doesn't matter. You can use that to populate your graph and try and create your visualization. And another one in relation with text analysis and NLP, natural language processing. Where are these techniques used in CovidGraph? Specifically, in the case, again, basically it's a question mostly for the database guys and girls from the project. But as far as I know, it's mostly about the feature where we were processing the abstracts and the titles and the text basically that we have for the publications and the patents, and where they are mentioning those genes. And while it seems simple to actually find these mentions in the text, it's actually a pretty difficult topic, because there's a lot of ambiguous names specifically for the genes. There's synonyms for genes, and sometimes genes are just like two-letter words, not words, just two characters, and they can also appear in a text without actually referring to that gene. So that's where we're using NLP techniques and mostly the named entity recognition techniques to find the connections between the papers and the genes mentioned in those papers. And there could be more. I think there are actually plans to do more, to do more text mining and to get more information from specifically these texts. But I think this is still one place where we are hoping for input from the community, because it's really I think it's probably the most difficult part in the job that we have. And so luckily I'm not part of that group, because I'm really just the visualization guy. So yeah, unfortunately I don't know about the current state about this, but I can connect you with those in our team who know more about that. Okay. Yeah, I would like to see the code of the application. Show me Cypher queries. Yeah, I was expecting this question to come earlier, actually. The application that I showed you, as I said, it's really a JavaScript single-page application, and the main part that's really specific about our use case is just two places. So if you have your own database and want to try this with your data and to create basically a structurally similar application, you should be able to do that in almost no time. Basically, what you have to do is declare how these panels on the side, what information you want to see there, and how they can be retrieved from the database. And you declare, yeah, basically the schema of the database and what options you want to see in the context menu. And let me just show that by the example, but with this example. So we have this paper entity and with the genes. And as I said, there's a relationship between the paper and the gene, and it's actually a multi-hop relationship. And that's where we are using Cypher. And let me try to find this one. So we have this, there's basically only one class that's really specific to the application. And this is really, and that's the CovidGraph loader JavaScript file in this case. And it's declaring those entities and how they are related to each other. So we have this is the paper type. So, and we declare how the panel should be should display the contents, and that's basically just a Vue.js file, very simple HTML template. Could also be using React or AngularJS or whatever you like, but basically it's just accessing the database, the items that we get from the database, that we get back from the database, and then use the properties to render them on the screen. And for the relationships, we declare snippets of Cypher, and actually these are the snippets that have been more or less directly copied from the database explorer. When I created these transitive relationships before in the schema view, at the end of the creation, it asks you to the tool like shows you the query, and you can copy that query to your clipboard, and that's basically exactly what almost literally what we need in here. So for the publications, we declare that authors are, so this is, you will recognize if you know Cypher, this is basically a part of a Cypher query which only misses the match and return parts. So we declare the source of a query, which is the paper that the user clicked on, and then there's a relationship which in our database is called paper has author collection, and there's a special node with a collection of authors, and there's another relationship, and then there we get to the author node. And so this is how you declare the relationship between the multi-hop relationship between the paper and an author. And to get back to the gene relationship, paper gene, this one, this is really it's actually really long Cypher fragment over here, which starts with the source node paper and ends with the target with a symbol. It's actually pretty straightforward Cypher. It's really just elements and node labels and types of relationships. So you can add things like add conditional statements where you filter out certain collections. So if you say, let's say you don't only want to show relationships that are, I don't know, less than 5 years old, if that's even a thing. But you can add this to the Cypher in here, and the app, the framework will include this fragment of Cypher into its processing. And this is really all you need to do is declare one of these fragments for each relationship that you want to show in the Explorer. And there's, you also tell them what verb you want to use, and then it's this mentioned or mentioning in the other direction. So if this is the load mentioning papers and associated and related and expressed. So that is just to make it more accessible to the end users. So that's Cypher, but there's a lot more. Do get back to me if you want to hear more about this. I think otherwise this would get too long today. But as I said, all of the sources are available on GitHub for you to browse. They are not really that instructive because, well, we created them in our spare time. You know, it's it was kind of like a hobby. So may not be that well documented. If you're looking for nice documented demos, please do take a look at the official Neo4j demos and the yFiles demos, or get back to me. Okay, another question. What, are we through yet? Can we use this for our database too? Yeah, I think I said this already. It doesn't have to be the CovidGraph DB, or as I said, it doesn't even have to be Cypher or Neo4j. Of course, they work perfectly with yFiles, but it doesn't have to be. As I said, it could be any source and any way, as long as you get that data to the client. And one last, it's always the same question: how many nodes can you display? I don't know. I haven't tried. The question should actually be, how many nodes should you display? Because if you can display 1 million elements, it might look really beautiful, but it's probably rather useless. So my answer always is, try to display as few nodes as possible. Even if you can more, you should try to not do that. And typically the question that your users have is not how many nodes are connected to a certain element, but they really have more specific questions, but like, how is this element related to this other one, and so on. And with interactivity and a sophisticated user interface, you can provide much better answers to your users than any just huge diagram or basically piece of artwork would be able to show or convey that information. Because if, as I said, if it's hundreds of thousands or millions of elements, sure looks nice, but yeah, probably useless. I hope that answers the question. Yeah, I think we're through. One last over here. No. Where is it? Yeah, it's almost the same. How scalable, responsive is the CovidGraph? What happens? Yeah, it's almost the same question. What happens if we load thousands of nodes and edges? Right now, the application probably gets slower. It shouldn't crash. I think it would probably still work with 100,000 nodes or so. It wouldn't be a pleasure to work with, not only because of the things that I just mentioned, also because performance will go down. This application really isn't optimized for large performance, for performing really good on large graphs. So what we're using as a technology in this specific demo is SVG rendering. And even though we use level of detail where we remove things like the labels, at some point this will get slower. As I said, I think it will become unusable simply because of the number of elements. That's probably earlier. But if you really want to show many elements with yFiles, you can go. Neo4j, of course, goes up into the millions, and yFiles into the billions. Sorry, but with yFiles, you should be probably switching to WebGL, which is also supported, and you can dynamically switch between SVG and WebGL or Canvas to render graphs of, well, tens of thousands of elements if you want to. Can you do a brief demo showing how a user would use it? I don't think I understand this question. Should use what? Could you maybe add more information? What to use what specifically? D point endpoint. Can you please D dot David, could you please clarify what you mean by using it? Is it Neo4j, our app, the Explorer, the programming library, or something else? Maybe try, coming from user perspective, what they would be seeing on your COVID docs. Yeah, basically this is what I said before. When you go to CovidGraph.org, and if you specifically are looking at the application that I showcased today, which is this one, this is really what happens. So you can do that right now. You can go to CovidGraph.org, click on this. This is an image, and then it will load this. As I said, this is where it all starts. Pretty empty canvas, and you get to fill it with your initial queries, and then you can populate your drawing. And this is how a user could use it. We built this initially without actually, that was a problem. We really didn't know exactly what researchers are probably asking, what kind of questions researchers would probably be asking. So this is a pretty generic application. It basically only lets you search and explore, but it doesn't really answer very, very specific, unique questions that our users might have. We really depend on your feedback here. So if you say, that's all good and fine, but what I really need to know is, for example, I don't know, what genes did Pfizer mess with in the recent years? Then you probably can't formulate that question right now. But it would be really, really easy to add this use case to this application, because we, as long as we have that information in the data, and you can tell us how you would like to ask that question, we or anyone, it doesn't have to be us, could be implementing this with the help of our tools. So there could be here, like, there's question 42, and now you enter the details that we need to, that really make the specific question unique, like which company do you want to know? I know how many patents they have been publishing in the recent years concerning this and that, this and that. Then you could just enter the name of the company, and then we would be running those queries and presenting the results in the form of a graph, if that's a useful answer. Or if it's not, maybe just a number, then of course we could just be presenting a number. But this is what I showed before is what is the interface that we created, and it's a very generic one. Adding more use cases is something that, yeah, can be done and should be done in order to become really useful. So that's why we really depend on your feedback and on the feedback of the research community, because then we can really make a great user experience, and not just a good one or just an outstanding one, but an awesome user experience. Okay. Cool. So I think any questions is now. Thank you. Are now, I hope, are answered, and if not, I will go through them in your emails and so on. Thank you very much for joining. Please visit our website on CovidGraph.org or the ones of my company if you're interested in the visualization in general. And let's just go back to the first one. Follow us on Twitter @CovidGraph, or on LinkedIn, find us, company CovidGraph, or on GitHub /CovidGraph2. Thank you for your attention. Have a good evening, and goodbye.